Okay. So, do you think that there's a gap in the market for the product of this brief?
For a low energy home that's able to generate energy and is efficient in using the energy, it's something that a lot of people are exploring at the moment. I think there's a lot of demand for low energy homes. I think the sort of challenge has always been whether the additional costs of producing something that's that energy efficient and that generates its own energy can be justified in terms of the ongoing life costs of the building, and it's a debate that's been going round and round quite a lot recently. Okay. I think there is definitely a market for it. I think it's a real shame because up until 2 or 3 years ago, the government had set itself a target that all new homes that were built in the UK were going to be built to a zero energy standard. Okay. Where any energy that they used in terms of heating and lighting them was going to be offset against energy gained through renewables that were sort of part of the building, and that was going to be across the board. All new houses were going to be like that, but the government dropped that, as a part of their kind of austerity and trying to reduce red tape on the construction industry. They abandoned all. Was it
because you wouldn't make profit from it, the government?
I guess they were lobbied by contractors who were saying it's going to be expensive and it's going to reduce the number of houses built. But it's a real shame because everybody in the industry was gearing up to producing zero energy homes as the sort of default mode for everything from 2016 onwards, and they just very quietly just dropped it as a thing. So there's I think a lot of disappointment. There was an expectation, and in a way, when you ask whether there's a market for it, it's something that we need to do. I think given that the effects of global warming that are happening at the moment, I think everybody acknowledges that we need to take fairly substantial action. And it's a shame that the government hasn't made sure that it's a requirement rather than being something that's sort of driven by the market.
Okay. Second question. I intended for my product to be partly built by the users and people interested in construction, people on work experience, volunteers, and just to basically get the public involved. Mm-hmm. How practical do you think this is? Like, will people want to have a part to play in the building of their home?
I think definitely people do want to have a part to play in how they build their home. I think that increasingly people are exploring the idea of self-build and custom build as sort of ways forward to address housing need. I think it's something that's been picking up steam a lot in the last few years. For a number of reasons, and one of them being cost, and it is that people are feeling kind of priced out of the housing market, and the perception is that one way of addressing this is to allow people to get more involved in the construction of their homes, and I think there's no reason why it shouldn't be possible. I think it needs a lot of training. There's skills involved in the construction industry, but actually the reality is that there is a lack of skilled workforce, and at the moment there's a real demand for new housing. We need to be building more housing, and actually there isn't the capacity in the industry at the moment. There's just not enough people who are not enough skilled carpenters or plumbers or all the people providing the trades. So actually, to train people through building their own homes ought to be a fantastic idea. It should be something that people ought to be doing. The challenge that you've got in the self-build market and in the custom-build market is that in order for somebody to build their own house, you need to be raising quite a lot of money to do that. You need to borrow money. If you're going to build your own house, you need to take out a self-build mortgage. And in order to fund the borrowing, you need to have a job with a steady income coming in. And the challenge is, how can you have a job with a steady income and build your house at the same time? It's an incredibly difficult thing to balance, and I think that's the challenge, just how you fund this kind of work, how people have the time to build and also to raise money they need to live at the same time.
So maybe not the people that are going to live in the home, but could we encourage anyone who's interested in construction to come along, maybe receive training, I think that's a really good idea. I think it should be something that we ought to be doing. There was an interesting survey in the Architects Journal recently, which is one of the main architectural magazines,
where they looked at the salaries of people in the construction industry, and the interesting thing that came out is that the salaries, electricians and plumbers were some of the top earners in the construction industry, and then carpenters were quite highly paid, and plasterers, bricklayers. Architects came quite a long way down the list below all of those people, because there's a lot of people, architects, wanting to design things, but actually there's not enough people doing plastering and bricklaying and all the other things, and so what's happening is salaries are pretty high in the construction industry, much lower in the architectural profession.
Wow.
So you can see how the sort of skills gap. A lot of people are thinking, I'm going to have a career in architecture as a good career, or actually people perhaps ought to be saying, I'm going to have a career in construction, because there's much more prospects than that.
Okay, wow. So that's a good thing to encourage people to do.
It's very good to encourage more people to get involved in the construction industry, because we need more capacity in the industry, definitely. Yeah.
Nice. Okay. Yeah, it's good. In what ways can, just list a few ways that the energy efficiency in a build can be increased?
Energy efficiency can be increased in a number of different ways. There's a project I'll talk about briefly here, which we've completed in North Bristol, some council housing built to passive house standards in Hembury in Bristol. And passive house is a really good strategy for reducing energy use in the buildings, and the key components of a passive house design. Firstly, everything needs to be very well insulated, so you need thick walls, a lot of insulation in them. All the windows need to be triple glazed.
What sort of diameter of walls, if that's the wrong word?
Well, you want about this much insulation, so you probably want about 300 millimetres of insulation in the wall somewhere. If you've got a timber frame building, that can be in the depth of the timber frame, but if you're building a kind of concrete cavity wall brick building, then that has to be within the thickness of that, so it then starts to get quite thick walls.
Okay.
So typically on a passive house it will be somewhere between 40 centimetres and 50 centimetres thick, the walls. A lot of insulation is quite important. Second thing is you want the building to be very airtight. So a lot of heat is lost through gaps in a building, around the edges of the windows, around the floors, in all sorts of places. When you finish a building now, you have to air test it to see whether there's any leaks anywhere. And a passive house building has to be very, very airtight. So you've got to, if you're making it out of timber, you line the inside with a board, and then you tape to all the joints, and you air test it. You make sure it's not losing any air, because that's a big source of heat. So a lot of insulation, very airtight. You want to make sure there's no cold bridges, and by that you mean anything piece of structure which is both outside in the cold and inside the building forms a heat path for heat to be lost through the building. So if you look at the window over there, there's some bricks. It's very easy for heat to pass through the inside bricks into the outside bricks, and you lose it there. So it has to be very carefully designed, the structure of a building, to stop what we call cold bridging. So particularly at the foundations, that's quite tricky. Around windows, everything that's on the inside and the outside of the building has to be separated by something that's insulating. You can't have any structure. So even things like bits of screws and brick wall ties and things, they're quite small. Even those have to be designed in a special way to have non-metallic ties to stop the heat being lost through that process. Those are sort of three key elements of it. The other thing is ventilation. I've said it needs to be airtight, but at the same time you need fresh air in a building. You need to be able to breathe properly. You need to deal with the moisture that you get in a building. So you need a ventilation strategy which allows you to bring fresh air in without losing lots of heat. So what you use in a passive house design is something called an MVHR, mechanical ventilation and heat recovery. It sounds quite complicated, but it's quite a simple idea really, is that you're bringing fresh air in from the outside and you're extracting warm air from the inside and taking it out, but in between it goes through a heat exchanger, so you're pulling all of the heat out of the extract air. So you've got an extract fan in the bathroom, there's an extract fan in the kitchen, and you're passing all of that warm air through a heat exchanger and heating the air that you're bringing in from the outside. So you get fresh air from the outside, but you're preheating it so that you don't lose that energy through the ventilation system. So those are the sort of key components of the passive house. The other thing that might be worth thinking about is how you use natural what we call passive solar gain, so how you use the sun's natural heat to help the heating. So if what you want to do generally is to make sure there's lots of windows on the south side of a building and hardly any windows on the north side of the building, so that you can so you can benefit from the from what we call passive solar gain to heat the building, and that has a huge impact. In our office, a lot of windows around there. We haven't got a very good heating strategy in here. It gets very cold in the winter, but on a sunny day, the whole thing heats up incredibly quickly because we've got a lot of south-facing windows, and it's using that strategy, quite an important part of saving energy too.
Okay. How ideal is cob as a wall solution in this country?
Cob.
Yeah.
Cob is quite tricky in terms of weathering, so it's a very natural material. It's low carbon in terms of its the embodied energy that it has in it. So it's kind of natural, it's breathable, it's low carbon, it has good insulating properties. The problem with it is that it weathers very badly, so you need to protect it externally somehow. There's sort of examples of different buildings around the country, but one way of doing that is to have very big roof overhang so it doesn't get rained on the outside of the building. But the critical thing with that is how you treat the outside of it. So it can be good. Well, I think the other thing to think about in terms of energy in buildings is that there's two sorts of energy. If you think about the energy that a building uses in its lifetime, there's two general areas. One is called embodied energy, and that's the energy that a building uses it in its construction. So all of the energy used to manufacture bricks or manufacture windows, the energy you need to transport all of those materials to site, all of the energy that the builders use in their cars. It's called embodied energy, and that's the energy that it's a huge amount of energy that it takes to build a building. The second part of the energy equation really is the energy in use, the energy that the building consumes for heating and lighting and other things. And I guess to really look at the equation, you need to kind of look at both sides of the equation to make a judgment about energy use in buildings. So something like cob is very good in that it's very low energy, it has very low embodied energy, but it can be part of a strategy to provide a kind of very insulated building too.
Okay. Could you give any, I know it's general, but could you give any knowledge on how a few sections of a home are connected? So maybe the stud partition walls, or how they're basically slotted together. Are there any slottings, or is it?
There's lots of different ways of putting together buildings, and it sort of depends what scale you're building at and how you're building them. The building I was talking about here, these council housing blocks, it's a timber frame building inside. The timber frame in this instance is made in a factory, because there's lots of advantages of making things in a factory, so that it has cassettes, which are big panels of timber with the sort of window openings all formed in them, and they put insulation in on site, they put membranes on these panels, and then they bring them on a lorry to site and crane them in. So they get assembled on site, it's big panels, almost like you're putting Lego together. And that allows it to be assembled very quickly. It has some various benefits. One benefit is that you can pay much better attention to sort of the detail and the kind of quality control by doing it in the factory. You're not building it in the rain and wind and everything. You've got much better control conditions to put it together. And it means when it comes to site, it can happen much quicker than it can if you're building it on site. And in that situation, there is a certain amount of slotting in that you would lay wall plates around sole plates around the bottom of where you're going to put the walls, and they would be fixed to the concrete foundations or the slab at the bottom. And as the crane comes in, there will be sort of little locating things that you bring them in and you kind of slot it into place, and then you'll sort of nail or screw it to fix it in position. The other way of doing it is on a small project you might what you call stick build it, which means to build it on site. They'll still tend to do it in panels on the floor and then lift those panels up and then sort of screw them into place. So, but in terms of internal stud work, I mean, it's quite interesting. Quite often that will happen at last, because what they'll tend to want to do is to get the outside envelope of the building up as much as possible and as quickly as possible, so they can get it weatherproofed, stop the water coming in, and then as long as they're not structurally supporting walls, the sort of internal timber partition walls will go on towards later on in the process.
Okay.